The visitor that changed everything. The night of September 3, 2024, began like any other at the Crimean Observatory. Telescopes swept across the night sky, capturing images of distant asteroids, forgotten comets, and cosmic dust. But that night, something extraordinary appeared on the sensors, something that shouldn't have been there. A luminous point moving at dizzying speed was crossing the solar system on an impossible trajectory. It wasn't coming from the asteroid belt. It wasn't a periodic comet. It came from the depths of interstellar space, from a place so distant that light from the nearest stars took years to reach us. Astronomers called it 3I Atlas, the third interstellar object ever detected by humanity. But this one was different from the others. It didn't resemble Oumuamua, that strange cosmic cigar that visited us in 2017. It wasn't like Comet Borisov, which briefly greeted us in 2019 before disappearing into the darkness. 3I Atlas was different, terrifyingly different, and the more we observed it, the more questions arose. Questions that challenged everything we thought we knew about the universe. Questions that forced us to consider possibilities that, until recently, existed only in the pages of science fiction. This is the story of that discovery, the tale of how a point of light changed our understanding of the cosmos, and perhaps, just perhaps, proof that we are not alone. Chapter 1. The First Discovery. September 3, 2024. Crimean Observatory, Atlas System. When Gennady Borisov pointed his telescope toward the constellation Ursa Major that early September night, he wasn't expecting to make history again. 5 years earlier, he had discovered interstellar comet 2I Borisov, the second known visitor from beyond our solar system. That feat had made him a legend among asteroid hunters, but what he was about to find would surpass everything before. The automated ATLAS system, Asteroid Terrestrial Impact Last Alert System, had been designed to detect potential threats, asteroids that could collide with Earth. Its cameras captured the sky every night, comparing images to identify moving objects. And that night, the algorithm found something. A faint object, barely visible, moving among the stars. Its speed was remarkable, approximately 25 miles per second, too fast to be an ordinary asteroid. Its trajectory was hyperbolic, meaning it wasn't gravitationally bound to the sun. It came from outside, very far away. The first preliminary calculations left Borisov breathless. The object had entered the solar system from an unusual direction, with an orbital inclination of nearly 90 degrees relative to the ecliptic plane where planets orbit. It was as if someone had thrown a stone from above, perpendicularly crossing the flat disk of our planetary system. But there was something else, something that didn't fit. The apparent magnitude of the object was strangely bright for its estimated size. If it were a simple asteroid or comet, it should be much fainter. Comets usually have a coma, a diffuse cloud of gas and dust that reflects sunlight. But this object showed no coma. It was compact, solid, point-like, like a star, or like something made by intelligent hands. Borisov immediately alerted the international astronomical community. Within hours, telescopes from around the world turned toward the coordinates. The W.M. Keck Observatory in Hawaii, the Very Large Telescope in Chile, the Hubble Space Telescope. Everyone wanted to see the visitor, and what they saw left them perplexed. The object's spectrum was anomalous. Normally, asteroids and comets show characteristic spectral lines, silicates, ices, organic compounds. But 3I Atlas's spectrum was almost flat, without distinctive features, as if its surface were incredibly smooth and reflective, metallic, perhaps. The scientific community quickly divided. Some argued it was a new type of interstellar object, perhaps a fragment expelled from a distant planetary system by cosmic catastrophe. Others, more cautious, preferred to wait for more data before speculating. But there was a small group, led by the controversial astrophysicist Avi Loeb of Harvard, who dared to say aloud what many thought in silence. What if it wasn't natural? September 10, 2024, 1 week after discovery. Data kept arriving, and each new analysis deepened the mystery. The object measured approximately between 650 and 1,300 feet in length, according to estimates based on its brightness and reflectivity. Its exact shape was difficult to determine, but it appeared elongated, possibly cylindrical or ellipsoidal. Its velocity relative to the Sun was 24.7 miles per second. To put it in perspective, that's more than 88,000 miles per hour. At that speed, it could cross the distance between Earth and the Moon in less than 3 hours. It was fast, yes, but not unusually fast for an interstellar object. Oumuamua had traveled at similar speeds. What was truly strange was its trajectory. Orbital calculations showed it had passed near the Sun on August 28, 2024, just 6 days before its discovery. At that point, its perihelion, minimum distance to the Sun, was approximately 0.65 astronomical units, about 60 million miles, closer than Venus's orbit. Any normal comet at that distance would have heated up intensely, releasing gases and forming a spectacular tail, but 3I Atlas showed none of that. It passed near the nuclear furnace of our star and emerged intact, unfazed, as if it had a protective shield. Skeptics argued it could be a rocky asteroid without volatile ices. Such objects can approach the Sun without developing comas. But then why was it so bright? Rocky asteroids are generally dark, with low albedos, reflectivity. This object seemed to reflect light much more efficiently. Dr. Loeb wasted no time presenting his hypothesis to the media. At a press conference that went viral, he declared, "We have an object coming from interstellar space that doesn't behave like a comet, has anomalous brightness, and passed near the Sun without flinching. If it were an artifact, what characteristics would we expect it to have? Exactly these." The scientific community reacted with understandable skepticism. Occam's razor suggests that, among multiple explanations, the simplest is usually correct. And the simplest explanation was that it was a rare but not impossible natural object. However, data kept arriving. And it didn't help calm speculation. September 20th, 2024. Rotation analysis. One of the most useful methods for characterizing distant objects is measuring how their brightness varies over time. When an asteroid rotates, if it has an irregular shape, its brightness increases and decreases periodically as it presents different areas to our view. This is called a light curve. Astronomers expected 3I Atlas to show regular variations, and it did, but in a strange way. The rotation period was approximately 6.7 hours, quite fast for an object of that size, but not impossible. What was puzzling was that brightness variations were very small, barely 10 to 15%. For an irregular natural object, we would expect much greater variations, especially if it's elongated, as some estimates suggest. Unless the object were almost perfectly symmetrical, like a perfect cylinder, or a sphere, or something designed to minimize aerodynamic perturbations during a long interstellar journey. We're seeing a level of symmetry that's statistically improbable for a natural object, commented Dr. Karen Meach of the University of Hawaii's Institute for Astronomy in an article published in Nature. "I'm not saying it's artificial. I'm saying we don't understand how nature could create something like this." Avi Loeb, of course, was more direct. "If it walks like a duck and quacks like a duck, maybe we should consider it might be a duck, or in this case, a spaceship. October 1, 2024, first high-resolution image. The James Webb Space Telescope had finally captured a clear image of 3I Atlas. Well, clear is a relative term when we're talking about a 1,000-foot object at a distance of over 120 million miles. But it was the best image to date, and what it showed was disturbing. The object wasn't irregular or rocky. It appeared to have defined edges, flat surfaces. Resolution wasn't sufficient to see details, but the general impression was of something manufactured, not sculpted by eons of random collisions in deep space. The image was leaked to the press before official publication. The internet exploded. Conspiracy forums worked overtime. Social media flooded with memes, theories, and heated debates. Hashtag 3I Atlas became a worldwide trend for days. NASA issued a cautious statement. Preliminary images from the James Webb Space Telescope show interesting features that require further analysis. We urge patience while the scientific community evaluates the data rigorously. But the genie was already out of the bottle. Chapter 2. Anomalous Characteristics. October 5, 2024. Detailed spectral analysis. While the world debated whether we were witnessing the discovery of the century or simply a space rock with a curious shape, scientists continued their meticulous work. Spectrographs from the planet's most powerful telescopes analyzed every photon of light reflected by 3I Atlas, searching for clues about its composition. And what they found only deepened the enigma. The object's reflection spectrum was extraordinarily flat in the visible and near-infrared range. For the uninitiated, this means it reflected all wavelengths of light almost uniformly, without preferentially absorbing any specific color. It was like a perfect mirror. Common asteroids have characteristic spectra. C-type asteroids, carbonaceous, are dark and absorb much light. S-type, siliceous, show signs of minerals like olivine and pyroxene. M-type, metallic, exhibit characteristics of iron and nickel. But 3I Atlas didn't fit any known category. It's as if its surface were made of some type of highly polished metal, declared Dr. Eno of the European Southern Observatory. Or a material we don't know. The reflectivity is on the order of 60 to 70%, which is incredibly high for a natural space object. To put this in perspective, the Moon has an albedo of barely 12%. Comets typically between 4 to 6%. Even the brightest asteroids rarely exceed 30%. But 3I Atlas reflected more than 60% of the light it received. It was almost as reflective as polished aluminum. The scientific community divided into three main camps. The first group, the conservative naturalists, insisted there must be a geological explanation. Perhaps the object was covered with crystalline water ice, though that didn't explain why it didn't evaporate near the sun. Or maybe it was a fragment from the metallic core of a destroyed planet, polished by millions of years of micrometeorite erosion. Improbable, but not impossible. The second group, the cautious agnostics, admitted the object was truly anomalous, but refused to draw hasty conclusions. They needed more data. Always more data. Science advances slowly, they argued, and extraordinary claims require extraordinary evidence. The third group, small but vocal, led by Avi Loeb and discreetly supported by some renowned scientists who preferred not to expose themselves publicly, posed the forbidden question: what if it was an extraterrestrial probe? October 12, 2024. The temperature mystery. Infrared telescopes provided another puzzling datum. The surface temperature of 3I Atlas was abnormally low for an object that had just passed so close to the Sun. When an object approaches our star, its surface heats up intensely. At 3I Atlas's perihelion distance, 0.65 AU, the temperature should have reached about 750 to 930 degrees Fahrenheit, enough to boil water and volatilize many compounds. Thermal models predicted the object should still be releasing that accumulated heat, cooling gradually for weeks. But infrared measurements from the Spitzer Space Telescope before its final decommissioning and the James Webb showed that 3I Atlas was surprisingly cold. Its surface temperature was barely 180 to 200 Kelvin, about -135 to -100 degrees Fahrenheit, much colder than expected. How was this possible? There were three main explanations. First possibility: the object had an extremely high heat capacity. That is, it could absorb enormous amounts of heat without increasing its temperature much. This would require a very specific composition, perhaps some type of exotic material rich in methane or ammonia ices. But then why didn't those ices evaporate near the sun? Second possibility: the object had some active cooling mechanism. Skeptics mocked this idea, but technically it wasn't impossible. If there were internal cavities or some thermal dissipation system, but that implied design, engineering, artificiality. Third possibility: our understanding of the thermodynamics of interstellar objects was incomplete. Perhaps there were physical processes we hadn't considered. Space is a laboratory full of surprises, after all. Dr. Michio Kaku, theoretical physicist and science communicator, commented in a television interview, "If I were an advanced civilization and sent an interstellar probe, I would certainly equip it with thermal management systems." Interstellar travel is brutal. Temperatures vary from near absolute zero in deep space to hundreds of degrees near stars. A probe would need thermal protection, just like our own spacecraft. His words resonated with millions of viewers, but also attracted criticism from more conservative colleagues who accused him of feeding public hysteria without solid foundations. October 25, 2024. X-ray analysis and radio emissions. The planet's great radio telescopes, including the Very Large Array in New Mexico and the ALMA system in Chile, scanned 3I Atlas looking for any type of electromagnetic emission. If the object was technological, it might be emitting signals, residual radiation from power systems, or some type of electromagnetic leakage. The results were mixed. No obvious radio signals were detected. There were no modulated transmissions, no patterns suggesting intelligent communication. That was reassuring to some and disappointing to others. However, X-ray telescopes, including the Chandra X-ray Observatory, detected something peculiar: weak but constant X-ray emissions coming from the object. They weren't intense, but they were there. X-ray emissions from asteroids and comets are extremely rare and usually associated with the interaction of solar wind with released gases. But 3I Atlas showed no signs of outgassing. So where were those X-rays coming from? A natural explanation was fluorescence, solar X-rays hitting the object's surface and being re-emitted at slightly different wavelengths. This is common in asteroids, though usually very weak, but the intensity and spectrum of 3I Atlas's emissions were slightly different from expected. The X-ray emissions have a high energy component that doesn't fit perfectly with solar fluorescence models, explained Dr. Natalie Batalha, astrophysicist at MIT. It could be some type of internal radioactive process, perhaps decay of heavy isotopes, or it could be something else. That something else remained unspecified, but everyone understood the implication. If the object contains some type of nuclear reactor or exotic energy source, X-ray emissions could be a natural consequence. November 1, 2024. The mass and density debate. Determining the mass of a space object without approaching it is incredibly difficult. Normally, astronomers observe how the object's gravity affects nearby bodies, but 3I Atlas was alone in empty space, with no satellites or companions that could reveal its mass through gravitational perturbations. However, there were indirect methods. If you knew the object's size, estimated by its brightness, and could infer its density based on its spectral composition, you could calculate an approximate mass. The problem was that all density estimates came out strange. If the object was primarily rock, its mass should be about 110 to 220 million pounds for a 1,000-foot body. If it was metallic, iron-nickel, it could be double, but trajectory models and the way it responded to solar radiation pressure suggested it was less dense than expected. Solar radiation pressure is the force exerted by solar photons hitting an object. It's weak but measurable, especially for small, highly reflective objects. By analyzing small deviations in 3I Atlas's trajectory caused by this pressure, scientists could estimate its mass-to-area ratio, and the numbers didn't add up. The object appeared to be too light for its size. "It's as if it were hollow," commented an anonymous researcher leaked to the press. Obviously, it can't be literally hollow, but the apparent density is only 1.5 to 2.0 grams per cubic centimeter. That's less dense than many terrestrial rocks, which have densities of 2.5 to 3.0 grams per cepede. It's more similar to porous ice or a structure with large internal voids. NASA quickly issued a correction. Density estimates are highly uncertain due to multiple assumptions involved. We shouldn't draw premature conclusions about the object's internal structure. But the damage was done. The idea that 3I Atlas might have internal cavities, compartments, empty spaces, was too tempting for the public and media. Speculation about ship hangars, cargo bays, or crew quarters flooded the internet. November 10, 2024. The absent magnetic field. Magnetometers aboard some space missions that happened to be in favorable positions attempted to detect any magnetic field associated with 3I Atlas. Metallic asteroids sometimes have remnant magnetic fields, vestiges from when they were part of larger planetary bodies with molten cores. But 3I Atlas showed no detectable magnetic field. This was consistent with a non-metallic object or metal without remnant magnetization, but it was also consistent with advanced materials designed to minimize magnetic signature, like those used in stealth submarines to avoid detection. Of course, it could also simply mean the object wasn't magnetic. End of story. But in the context of all other anomalies, each new datum that arrived seemed to feed more questions than answers. Meanwhile, on social media, the hashtag 3iAtlas had accumulated over 500 million mentions. Conspiracy theories flourished. Some claimed governments were hiding information. Others insisted it was definitive proof of extraterrestrial intelligence. Skeptics mocked the collective hysteria and called for calm. Memes were inevitable. Images of 3I Atlas with googly eyes, photoshopped with neon lights, compared to ships from Star Wars and Star Trek. Popular culture had adopted the object as its own. But behind the jokes and crazy theories, there was a genuine question that troubled even the most rational scientists. What the hell is this thing really? And most disturbing of all, we still hadn't seen its strangest behavior. That was yet to come. Chapter 3. Hypotheses and Controversies. November 14, 2024. The scientific community in crisis. A month and a half after the discovery, the international astronomical community found itself in a state of unprecedented agitation. What had begun as an exciting detection of an interstellar object had become the most polarized scientific debate of the decade. Academic conferences transformed into dialectical battlefields. Scientific papers flew back and forth, some defending increasingly elaborate natural explanations, others daring to mention the word many considered taboo: artificial. The tension reached its peak during the International Astronomical Union Congress held virtually in November 2024. More than 3,000 astronomers from 80 countries connected to discuss the three-eye atlas phenomenon. And what should have been a civilized, scientific exchange became a spectacle of accusations, counter-accusations, and personal confrontations. The natural hypothesis, an exotic but explainable object. Dr. Marco Micheli from ESA's Near-Earth Object Coordination Center led the defense of natural explanation. In his meticulously prepared presentation, he proposed a series of scenarios that could explain the observed anomalies without resorting to extraterrestrial intelligence. "Let's consider the facts objectively," Micheli began, his voice calm but firm. "We have a reflective object with an apparently smooth surface. This could simply be a fragment from the mantle of a destroyed planet, rich in bright minerals like feldspar or quartz. Nature can create very smooth surfaces through geological processes." Regarding the apparent low density, Micheli suggested the object could be porous, filled with cavities created by impacts or by sublimation of volatile materials during millions of years wandering through interstellar space. "Comets are notoriously porous," he explained. "Some have densities of only 0.5 grams per CPQ. Why couldn't 3I Atlas be a special type of inactive comet?" As for X-ray emissions, he proposed they could be due to the presence of naturally radioactive elements like potassium-40 or thorium-232, which exist in many rocky bodies and produce radiation naturally. "Earth itself is radioactive," he reminded the audience. "This is not evidence of technology." His presentation was applauded by a significant portion of the audience. Occam's razor remained a powerful tool. Faced with the choice between rare asteroid and alien ship, the first option was infinitely more probable. But then Avi Loeb intervened. The artificial hypothesis. When science encounters the impossible. Dr. Abraham Avi Loeb, director of Harvard's Institute for Theory and Computation and former chair of the astronomy department, wasn't just any scientist. With more than 800 published articles and an impeccable track record in theoretical astrophysics, his credentials were impeccable. But his willingness to seriously consider the possibility of extraterrestrial technology had made him a controversial figure. "Colleagues," Loeb began, his Israeli accent evident even in English, "we've been saying for decades that the search for extraterrestrial intelligence is legitimate science. We send radio signals into space, we look for technosignatures on exoplanets. But when an object with technological characteristics appears literally in our backyard, we refuse to consider it. Why?" Loeb proceeded to systematically dismantle natural explanations. The object couldn't be an inactive comet because comets have very low albedos, not 60 to 70%. It couldn't be a polished metallic fragment because then it would be much denser. It couldn't be a bright, porous rock because such materials didn't explain the observed flat spectrum. "Let's apply the principle of maximum likelihood," he continued. "What explanation makes the observed data most probable? An asteroid with a combination of properties we've never seen, requiring multiple improbable coincidences, or an artifact designed to travel efficiently through interstellar space, with reflective surfaces to minimize heating, light structure to facilitate propulsion, and perhaps internal systems producing the emissions we detect." The virtual room erupted. The chat flooded with comments, some supporting Loeb, others accusing him of sensationalism and pseudoscience. Dr. Micheli responded vehemently. "Dr. Loeb, you're appealing to ignorance. Just because we can't fully explain something doesn't mean we should jump to the most extraordinary conclusion. History is full of phenomena that seemed inexplicable until we understood the underlying physics. Loeb wasn't fazed. Marco, I respect you deeply as a scientist. But tell me honestly, if an advanced civilization sent a probe to our solar system, what characteristics would you expect it to have? I would expect it to be light, to accelerate easily, to have reflective surfaces to manage heat, to be compact and symmetrical to minimize resistance from the interstellar medium. Exactly what we're seeing. Dr. Michio Kaku's intervention. The debate might have continued indefinitely if not for the intervention of Dr. Michio Kaku, world-renowned theoretical physicist and co-founder of string field theory. Kaku, known for his ability to communicate complex concepts to the general public, offered a perspective that resonated with many. Colleagues, we're asking the wrong questions, Kaku declared. We shouldn't ask, is it natural or artificial? We should ask, what evidence do we need to be certain one way or the other? Kaku proposed a rigorous scientific framework, a list of specific observations that, if confirmed, would decisively tip the scales toward one hypothesis or another. If we observe active propulsion, that is, changes in trajectory that can't be explained by gravity or radiation pressure, that would be strong evidence of artificiality. If we detect structured electromagnetic emissions, radio signals with non-random patterns, that would be definitive. On the other hand, if we find chemical compositions consistent with known astrophysical processes, if the light curve shows irregularities typical of natural objects, if we find evidence of space erosion, then we can be more confident in a natural explanation. His proposal was received with general approval. At least it gave a path forward that both sides could accept. November 20, 2024. The public debate intensifies. Outside academic circles, the world was fascinated and divided. Polls showed that approximately 35% of people in Western countries believed 3I Atlas was probably an alien probe. Another 40% thought it was natural but unusual. The remaining 25% had no opinion or didn't care. Television programs devoted hours to the topic. Science podcasts exploded in popularity. Hastily produced documentaries were being made at a frenetic pace. Netflix announced a 6-episode series about the discovery to premiere in December. But not everything was positive. Conspiracy theories proliferated. Some claimed 3I Atlas was an alien warship preparing to invade. Others insisted world governments had been in contact with extraterrestrials for decades, and this was part of a gradual disclosure plan. Apocalyptic groups predicted the end of the world. The UN issued a statement calling for calm and reminding that regardless of the object's nature, it posed no immediate threat to Earth. Its trajectory would take it far from the inner solar system, constantly moving away. November 25, 2024. The Space Mission Proposal. In a historic joint press conference, NASA, ESA, and the space agencies of Russia, China, and Japan announced they were evaluating the feasibility of sending an encounter mission to 3I Atlas. We recognize the exceptional scientific importance of this object, declared NASA's administrator. An in-situ mission would allow us to obtain data that would be impossible to get from a distance. We could analyze its composition directly, take high-resolution images, and potentially answer definitively the questions that torment us. However, there was an enormous technical problem. 3I Atlas was moving away, rapidly. To reach it, a spacecraft would need to be launched soon and travel at unprecedented speeds. Preliminary calculations suggested a complex gravity assist trajectory would be needed, using Venus, Earth, and possibly Jupiter to accumulate sufficient velocity. Even with an optimistic scenario, the mission would take between 8 and 12 years to reach the target, and that assumed launch within the next 2 years. Each month of delay would make the mission more difficult and expensive. The estimated cost was astronomical, between $18 billion and $30 billion, an investment comparable to the James Webb Space Telescope or the Apollo program. Was it worth it? Proponents argued, yes, absolutely. If there was even a 1% chance that Tri Atlas was technological, the benefit to humanity of confirming it would be incalculable. It would be the most important discovery in the history of our species. Critics pointed out that money could be used to solve urgent terrestrial problems: climate change, poverty, disease. Was it responsible to spend tens of billions pursuing what was probably just an interesting space rock? The political debate began immediately. In the US Congress, in the European Parliament, in the Russian Duma, in China's National Assembly, legislators debated the proposed budget. Some saw it as an investment in humanity's future, others as vain extravagance. November 30, 2024. The Open Letter. A group of more than 1,200 scientists, including several Nobel laureates, published an open letter addressed to world leaders. The text was clear and passionate. We find ourselves at a unique moment in human history. For the first time, we have a real possibility of determining whether we are alone in the universe. The object, 3I Atlas, presents characteristics that challenge our current understanding and deserve deep investigation. Whether it turns out to be natural or artificial, its study will teach us fundamental things about the cosmos. If it's natural, it will expand our knowledge of astrophysical processes and the diversity of interstellar objects. If it's artificial, it will forever change our view of our place in the universe. We urge the nations of the world to cooperate in funding and executing an encounter mission with 3I Atlas. This is not an enterprise of a single country or agency. It's an effort for all humanity. Future generations will judge us by how we responded to this moment. Did we have the wisdom and courage to seek answers, or did we let ourselves be paralyzed by fear, bureaucracy, and lack of vision? The choice is ours. The letter went viral. It was reproduced in newspapers around the world. It generated a popular movement supporting the mission. Online petitions gathered millions of signatures. But while the world debated politics and budgets, something was about to happen that would make all those discussions seem trivial. Atlas was about to do something no asteroid had ever done, something that would defy the laws of physics as we understand them, and when it happened, there would be no more room for doubt. Chapter 4. Impossible Maneuvers. December 3, 2024. The First Orbital Anomaly. Dr. Davide Farnochia from NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory had been monitoring 3I Atlas's trajectory with obsessive precision since its discovery. As a specialist in celestial mechanics, his job consisted of predicting exactly where each object in the solar system would be at any given moment, using Newton's laws and Einstein's general relativity. The mathematics were complex but well established. Given initial position, velocity, and knowing all forces acting on an object, mainly the sun's and planet's gravity, plus minor effects like solar radiation pressure, one could calculate its future trajectory with extraordinary precision. Farnochia had generated ephemerides for 3I Atlas, tables showing exactly where the object should be at each moment. His predictions had been accurate to a tenth of an arcsecond. The object behaved exactly as expected for a body under gravitational influence, until it stopped doing so. That morning of December 3, when Farnochia compared the most recent observations with his predictions, he noticed something disturbing. The object was slightly displaced from where it should be. Not much, barely 2.3 arcseconds, approximately the width of a human hair, seen from 30 feet away. For most people, this would be negligible. For an expert in celestial mechanics, it was terrifying. Impossible, he muttered, checking his calculations for the third time. He verified the observation data. Correct. He checked his gravitational models. Correct. He checked if he had overlooked any planetary perturbation. No, all planets were accounted for. The object had deviated from its predicted trajectory. It had accelerated. The phantom acceleration. During the next 48 hours, Farnokia and his team worked tirelessly. They needed to confirm it wasn't an observation error, a telescope calibration problem, or some other instrumental artifact. They requested confirmation observations from multiple independent observatories. All confirmed the same thing. 3I Atlas was moving away from the Sun slightly faster than it should. The acceleration was small, approximately 0.00003 meters per second squared, but unequivocally real. To put it in perspective, it was as if someone pushed a 2,200-pound car with a force of barely 1 ounce. Minuscule in absolute terms, but completely inexplicable for an object supposedly only under gravity's influence. Farnokia published a cautious technical statement. We have detected a non-gravitational component in 3I Atlas's trajectory. We are evaluating possible natural causes before drawing conclusions. But internally, he was deeply disturbed. He had seen this before, in another object. Oumuamua, the Oumuamua precedent. In 2017, when the first interstellar object, Oumuamua, crossed our solar system, it also showed similar anomalous acceleration. At the time, several natural explanations were proposed. The most accepted was outgassing, release of volatile gases, hydrogen, nitrogen, or carbon monoxide, acting like tiny rocket engines, gently pushing the object. This explanation had problems. Oumuamua showed no visible coma or gas tail. There were no detectable changes in its rotation that you'd expect from asymmetric outgassing. But it was the best natural explanation available, so the scientific community accepted it, albeit with some discomfort. Now, with 3I Atlas, the same explanation was offered again. Perhaps it was releasing gases we couldn't detect directly. Perhaps they were gases that didn't reflect visible light, but still exerted force. The problem was that 3I Atlas had passed near the Sun months earlier. If it was going to outgas, it would have been during perihelion, when heating was maximum. But it didn't then. Why would it start now, when it was colder and farther away? December 8, 2024. The second acceleration. Just when Farnokia's team was developing delayed outgassing models to explain the first anomaly, 3I Atlas did something even more puzzling. It accelerated again, but this time in a different direction. The first acceleration had been approximately along the object's direction of motion, moving it away from the Sun faster. This was consistent with outgassing from the Sun-facing surface, pushing the object forward. But the second acceleration had a significant perpendicular component. The object wasn't just accelerating forward, it was also slightly changing its direction of travel. This can't be random outgassing, Farnokia declared in an emergency meeting with international colleagues. Outgassing produces chaotic, irregular accelerations. This is directional, controlled. The magnitude of the second acceleration was similar to the first, about 0.00003 meters per squared, insignificant by terrestrial standards, but perfectly measurable by modern astronomical instruments, and perfectly inconsistent with any known natural process. The active control hypothesis. Avilob didn't waste time. Less than 24 hours after news of the second acceleration leaked, he published an article on his personal blog that went viral instantly. When a space object accelerates once in a direction consistent with natural forces, we can look for complex physical explanations. When it accelerates twice in different directions without apparent cause, we must consider the possibility that it's under deliberate control. Loeb proceeded to calculate the energy needed to produce the observed accelerations. Assuming a mass of 110 million pounds, a conservative estimate, the required force was approximately 1,500 newtons, equivalent to the weight of about 330 pounds on Earth. A technological civilization that can build interstellar ships can certainly generate 1,500 newtons of thrust, he wrote. A modest ion engine could do it. Solar sails, laser propulsion, even simple chemical reactions. The energy required is trivial for any advanced technology. His critics reacted quickly. Dr. Micheli published a counter-article arguing that asymmetric outgassing of exotic compounds like frozen molecular hydrogen or nitrogen could produce exactly the observed effects without requiring technology. The problem with Loeb's hypothesis, Micheli wrote, is that it violates the principle of parsimony. We're choosing the most complicated and extraordinary explanation when natural explanations, though improbable, remain possible. December 15, 2024, the pattern emerges. During the following week, 3I Atlas continued to be monitored intensely, and what astronomers discovered left them speechless. The object was accelerating periodically, every 6.7 hours, approximately coinciding with its estimated rotation period. A small impulse was detected, not always in the same direction, but following a pattern. As if something in the object activated once per rotation, producing a brief thrust. The data were unequivocal. This wasn't a random process. There was a temporal structure to the accelerations, a regularity that screamed design, not chaos. Dr. Paul Wiegert of Western University conducted an exhaustive statistical analysis. The probability that these periodic accelerations are a product of chance is less than 1 in a million, he concluded. This is a signal, not noise, but a signal of what? If it was technology, what kind of system would produce regular impulses each rotation? Some possibilities. Possibility 1. Directional mass ejection. The object could be expelling material in a controlled manner from a specific point on its surface. Each time that point rotated toward a particular orientation, perhaps toward the sun or toward a distant star, it activated, producing a small thrust. This would require propellant storage systems, valves, orientation sensors, technology. Possibility 2. Active solar sail. If the object had reflective surfaces that could be oriented, like panels or sails, it could be using solar radiation pressure more efficiently during certain parts of its rotation, but this also required active control. Possibility 3. Electromagnetic field. Some theoretical proposals for interstellar propulsion involve using magnetic fields to interact with the interstellar medium or solar wind. If 3I Atlas had some type of magnetic sail, the periodic impulses could be explained. But again, this implied advanced technology. All technological explanations converged toward the same terrifying conclusion. 3I Atlas wasn't an inert object. It was doing things actively. December 20th, 2024, the major maneuver. And then what some had feared and others had hoped for happened. On December 20th, 3I Atlas executed a significant trajectory correction maneuver. Over a period of approximately 3 hours, the object applied sustained thrust that changed its velocity by about 26 feet per second. It may not sound impressive, but for an object of its mass, it required enormous energy, approximately 400,000 megajoules, equivalent to the explosion of almost 220,000 pounds of TNT. And most notable, The velocity change was precisely in the direction needed to adjust its trajectory toward a specific target. Astronomers who analyzed the new orbit were astonished. Before the maneuver, 3I Atlas was on a trajectory that would take it out of the solar system toward the constellation Eridanus, without passing near any object of interest. After the maneuver, its new trajectory would take it to pass within barely 0.1 astronomical units of Proxima Centauri in approximately 6,000 years. Proxima Centauri, the star closest to the Sun, a star with known planets, including at least one in the habitable zone. It could be a coincidence. Perhaps the direction just happened to point there, but the odds of a random acceleration resulting in such a precise trajectory toward the nearest inhabited star were astronomically low. We can no longer ignore the obvious, Dr. Kaku declared in a television interview viewed by more than 100 million people. This object is navigating. It has a destination, and it appears to be a star system with potentially habitable planets. The global reaction. Panic wasn't long in coming. If 3I Atlas was a ship and was heading toward Proxima Centauri, did it mean it originally came from there? Had it completed a round trip? Or did it come from somewhere else and was simply using our solar system as a stopover? And the most terrifying question, why did it pass so close to our Sun? Interstellar objects don't need to approach stars so closely. They can pass at much greater distances. The fact that 3I Atlas passed within only 0.65 AU of the Sun, entering deep into the inner solar system, suggested it was deliberate. Was it observing us? Collecting data? Refueling somehow? Conspiracy theories reached unprecedented levels of hysteria. Global financial markets reeled. Survival bunker sales skyrocketed. Religious leaders offered varied interpretations, from divine sign to harbinger of apocalypse. The UN convened an Emergency Security Council session. For the first time in history, the agenda was coordinated response to possible contact with extraterrestrial intelligence. December 25, 2024. Christmas message. In an unprecedented attempt to calm the world population, leaders of major space powers issued a joint message on Christmas. Citizens of the world, the statement began, read simultaneously in dozens of languages. We recognize the uncertainty and fear many feel regarding recent discoveries about the object 3I Atlas. We want to assure you that, regardless of its nature, it poses no immediate threat to Earth. The object is moving away from our planet at great speed. Its observed maneuvers, though unusual, don't indicate hostile intent. If it's technological, it appears to be on an exploration or transit mission, not aggression. We have decided to accelerate the encounter mission. In the next 6 months, multiple space agencies will collaborate to launch a probe toward 3I Atlas. Our goal is to reach it within 8 to 10 years and obtain definitive data about its nature. Meanwhile, we will continue monitoring it constantly. We will keep you informed of any developments, and we ask you to maintain calm, rationality, and hope that, whatever 3I Atlas is, its appearance marks the beginning of a new era of discovery for humanity. The message was well received by some, considered insufficient by others, but at least it represented an attempt at unified global leadership facing something no nation could confront alone. Because the truth was now evident to everyone, the question was no longer whether we were alone in the universe. The question was, what did those visiting us want from us? Chapter 5. What's Inside? January 1st, 2025. The Year of Contact. The world entered the new year with a mixture of dread and fascination. Newspaper headlines were uniform in all languages. 2025, the year that will change human history? New Year's celebrations had a strange tone, as if humanity were collectively holding its breath, waiting for a revelation that could come at any moment. Meanwhile, in laboratories and universities around the world, scientists from multiple disciplines worked feverishly to answer an apparently simple but profoundly complex question. If 3I Atlas is artificial, how does it work? This wasn't mere academic curiosity. Understanding the internal structure and propulsion mechanisms of the object could offer vital clues about its creator's intentions, their technological level, and perhaps even their origin. The propulsion problem. Dr. Philip Lubin, physicist at the University of California, Santa Barbara, and pioneer in interstellar propulsion concepts, led an international team attempting to model possible propulsion systems that would explain 3I Atlas's behavior. Let's start with what we know, Lubin said in a virtual conference with more than 500 participating researchers. The object has demonstrated the ability to accelerate in a controlled manner. The accelerations are small but sustained. The total energy employed in the major maneuver of December 20 was approximately 400,000 megajoules. That gives us parameters to work with. Lubin proceeded to rule out several propulsion methods. Traditional chemical propulsion, impossible. To produce a velocity change of 26 feet per second in a 110 million pound object using chemical rockets, you'd need to carry millions of pounds of fuel. Tsiolkovsky's equations are unforgiving. The required propellant mass scales exponentially with desired velocity change. An object the size of 3I Atlas couldn't store enough chemical fuel and remain functional. Nuclear fission propulsion. Possible, but problematic. Nuclear fission engines are efficient but produce characteristic radiation we should have detected. Gamma rays, neutrons, radioactive fission products. Though the weak X-ray emissions we observed could be consistent with some type of well-shielded nuclear reactor, the levels were too low for an active propulsion system. Ion engines. Interesting. Ion engines accelerate charged particles using electric fields, producing small but very efficient thrusts over long periods. They're perfect for slow but steady space travel. However, they require enormous amounts of electricity. Where would 3I Atlas get it? Solar panels? At its current distance from the sun, solar panels would be inefficient. Nuclear reactor? We're back to the radiation problem. Solar sails or laser sails? Fascinating but insufficient. Solar sails use radiation pressure from light to accelerate. They're elegant, require no fuel, and are perfect for patient interstellar travel. But they produce accelerations in specific directions relative to the sun or light source. IATLAS's maneuvers included components that couldn't be easily explained by solar sails, especially after moving so far from the sun. Antimatter propulsion. Theoretically possible, but extraordinarily advanced. Antimatter is the most efficient fuel conceivable. Each pound of antimatter annihilated with matter produces 90 quadrillion joules of energy, E equals mc squared. With just a few pounds, you could propel a ship for years. The problem is, we don't know how to create, store, or use antimatter safely at macroscopic scale. If 3I Atlas used antimatter, we'd be looking at technology centuries or millennia more advanced than ours. My assessment, Lubin concluded, is that most likely it's some form of advanced electric propulsion powered by a compact, high-energy density power source we don't fully understand. Perhaps advanced nuclear fusion. Perhaps something more exotic. Internal structure. Speculative modeling. If they couldn't see inside 3I Atlas directly, scientists could at least try to infer its structure based on its observed properties. This gave rise to a series of fascinating speculative models. Model 1. The automated scientific probe Dr. Sarah Seeger of MIT proposed that 3I Atlas could be a robotic exploration probe, similar in concept to our Voyager or Pioneer probes, but infinitely more advanced. Imagine a probe designed to travel between stars, study planetary systems, and continue toward the next target, Seeger explained. Its internal structure could include scientific instruments, telescopes, spectrographs, particle detectors, magnetic field sensors, everything needed to characterize star systems from a safe distance. Communication system, antennas or transmitters to send data, perhaps toward their civilization of origin, though at interstellar distances, communications would take years or decades to arrive. Central computer, a sophisticated artificial intelligence capable of making autonomous decisions, navigating and managing systems during journeys that could last thousands of years. Propulsion systems, efficient engines for trajectory corrections and orbital maneuvers. Power source, long-duration reactors, possibly nuclear fusion or something more advanced. Shielding, protection against cosmic radiation, micrometeorite impacts, and extreme thermal variations. The beauty of this model was its simplicity. Robotic probes are concepts we understand. We already build them, though primitive by comparison. A civilization with centuries or millennia of technological advantage could easily create something like 3I Atlas. Model 2. The Hibernating Generation Arc. Dr. Kaku proposed a bolder alternative, a generation ship in low-power mode. Consider the possibility that 3I Atlas isn't just a probe, but a colonization vessel in transit between stars, Kaku suggested. Its interior could contain hibernation compartments, cryogenic chambers, or suspended animation technologies, maintaining biological passengers in stasis during the long interstellar journey. Genetic banks, stored DNA, frozen embryos, or complete genetic information from a civilization, ready to be reconstructed upon reaching the destination. Closed ecosystems, miniaturized biospheres that could be reactivated upon arrival, providing food and habitable environment. Molecular manufacturing, nanotechnology or advanced 3D printing capable of fabricating any tool or structure needed using materials from the destination star system. This model was more speculative, but explained why the object might be navigating so deliberately. It wasn't just a curious explorer, it had a specific destination, and possibly passengers waiting to arrive. Model 3. The Ancient Relic. British astrophysicist Martin Rees offered a more sober and perhaps more unsettling perspective. We must consider the possibility that 3I Atlas is ancient, Rees said. Very ancient. It could have been launched millions of years ago by a civilization that no longer exists. It could be operating on instructions programmed eons ago, blindly navigating toward a destination that perhaps no longer makes sense. This idea was both melancholy and terrifying. It would mean we were seeing the ghost of a dead civilization, its last message in a bottle floating in the cosmic ocean. It would also mean the galaxy could be full of such relics, archaeological remains of civilizations that rose and fell long before humans existed. If this is the case, Rees continued, then its internal structure could be partially degraded. Systems that failed millennia ago. Technologies we no longer understand even if we could see them. It would be like trying to reverse engineer an ancient smartphone without cultural context. January 10, 2025. Revised density analysis. A new, more detailed analysis of 3I Atlas's apparent density using improved data on perturbations caused by solar radiation pressure yielded fascinating results. The object appeared to have an average density of approximately 1.8 grams per cubic centimeter. For comparison, water 1.0 grams per cp, ice 0.92 grams per cp. Typical rocks 2.5 to 3.0 grams per cp. Iron 7.9 grams per cp. Aluminum 2.7 grams per cp. A density of 1.8 grams per cp is consistent with a hollow structure with relatively thin walls, explained aerospace engineer Robert Zubrin. It's exactly what you'd expect from a ship designed for mass efficiency. You don't want to carry unnecessary material on an interstellar journey. Every extra pound requires more energy to accelerate and decelerate. Zubrin proceeded to calculate possible structural configurations. If 3I Atlas were a cylinder 1,000 feet long and 165 feet in diameter, dimensions consistent with observations, and had an average density of 1.8 grams per cubic centimeter, then total volume, approximately 21 million cubic feet. Total mass, approximately 1.17 million tons, downward revision from earlier estimates. If walls had an average thickness of 16 feet of material with density 4 grams per cp, comparable to titanium or advanced composites, then the interior habitable volume would be about 16.6 million cubic feet. That's almost 17 million cubic feet of interior space, Zubrin noted with amazement. For comparison, the International Space Station has a pressurized volume of barely 32,000 cubic feet. 3I Atlas could have more than 500 times that space. You could store a small city in there, or a complete library of a civilization, or an entire forest in stasis. Enhanced James Webb Images. On January 15, 2025, NASA and ESA jointly published enhanced and processed images of 3I Atlas, obtained by the James Webb Space Telescope using multiple exposure stacking techniques. Although resolution remained limited by the enormous distance, the processed images revealed details that hadn't been appreciated before. The object showed clearly non-random geometry. There were straight edges, defined angles, what appeared to be discrete panels or sections on its surface. One end of the object appeared slightly brighter than the other, as if it had a more reflective surface or different orientation. Some analysts speculated it could be a forward shield designed to protect against interstellar dust impacts during high-velocity travel. The general surface appeared remarkably smooth at observable scales, without the impact craters you'd expect on an asteroid that had wandered through space for millions of years. This suggested either it was young, unlikely given its interstellar origin, or it had some type of self-repairing protective layer. The images were widely disseminated. CGI experts and spaceship designers from Hollywood were consulted to create artistic representations based on the data. Interpretations varied, but all converged on one undeniable truth. This didn't look natural. January 20th, 2025. The Radical Communication Proposal, Dr. Douglas Vakoch, president of METI, Messaging Extraterrestrial Intelligence, proposed something controversial, attempting to communicate with 3I Atlas. If there's any possibility the object contains artificial intelligence capable of responding, we should attempt to establish contact, Vakoch argued. We could transmit radio or laser signals in its direction using universal mathematical patterns any technological civilization would recognize. Prime number sequences, the Pythagorean theorem expressed geometrically, fundamental constants of physics. The proposal generated fierce debate. Proponents argued it was our best chance to get direct answers. If 3I Atlas was an intelligent probe, it might be programmed to respond to contact attempts. Opponents pointed out multiple dangers. First, transmitting powerful signals toward an unknown object could be considered imprudent. We didn't know its intentions. What if it interpreted our signals as hostile or threatening? Second, We could reveal information about our technology, exact location, beyond what they might already know, and capabilities. In science fiction scenarios, this rarely ends well for the less advanced civilization. Third, who decides what message to send and who speaks on behalf of humanity? The United Nations? A scientific consortium? The governments of space powers? The lack of global consensus was evident. In the end, a temporary compromise was reached. No deliberate transmissions would be sent toward 3I Atlas until there was greater international agreement. But radio telescopes would continue intensely monitoring any signal that might emanate from the object, because if 3I Atlas wanted to communicate, surely it would do so in its own way and at its own time. And perhaps, some thought with a mixture of hope and dread, that moment was closer than we imagined. Chapter 6. Consequences for Humanity. January 25, 2025. The UN Emergency Meeting. The General Assembly Hall at the United Nations in New York had never hosted a session like this. Representatives from 193 nations gathered in an extraordinary convocation to discuss something that, barely 6 months earlier, would have seemed pure science fiction. How to respond as a species to evidence of extraterrestrial intelligence. The UN Secretary-General opened the session with words that would be quoted for generations. Colleagues, delegates, citizens of the world, we meet today not as separate nations, but as representatives of the human family. The discovery of 3I Atlas has demonstrated something many suspected but few dared to state with certainty. We are not alone in the universe. This revelation poses questions that transcend politics, economics, or national borders. It forces us to rethink our position in the cosmos, and it demands we act with wisdom, unity, and long-term vision. The debate that followed was intense, passionate, and sometimes chaotic. Several opinion blocks formed, reflecting different visions of how humanity should proceed. The cautious observation bloc, led by representatives from Germany, Japan, and Canada, this group argued humanity should adopt a conservative and patient posture. We know practically nothing about 3I Atlas's creators or their intentions, declared the German ambassador. Until we have more information, our priority must be planetary security. I propose that, first, we massively increase our space monitoring capabilities. We need to detect any other similar object that might enter our solar system. Second, we invest in planetary defense technologies, not with warlike intent, but as prudent precaution. If we can deflect dangerous asteroids, we could also protect ourselves from artificial threats. Third, we establish clear international protocols on how to handle future contacts, who has authority to respond, and what information we share or don't share with extraterrestrial entities. This position was popular among nations with strong traditions of precaution and long-term planning. It reflected the underlying fear that humanity might be playing with fire when dealing with incomprehensibly advanced technologies. The active engagement bloc, headed by France, India, and Brazil, this group believed humanity should actively attempt to communicate with and learn from 3I Atlas. This is a unique opportunity in our species' history, argued the French representative. For decades, we've spent millions on SETI, searching for signals of intelligent life. And now that something, possibly intelligent, has visited us, are we going to hide in fear? It's absurd. I propose we send missions not only to observe 3I Atlas, but to attempt to interact with it. If it contains artificial intelligence, we should try to communicate. If it's an inert probe, we should study it in detail. The knowledge we could obtain about interstellar propulsion, advanced materials, perhaps even about the civilization that created it, could accelerate our technological development by centuries. This approach was attractive to nations with emerging space ambitions and cultures that valued boldness and rapid progress. It reflected the hope that extraterrestrial contact could be beneficial, a source of knowledge and advancement. The Total Transparency Bloc, a smaller but vocal group led by the Netherlands and New Zealand, insisted the greatest priority should be keeping the public informed. The greatest danger isn't 3i Atlas, declared the Dutch representative. The greatest danger is panic, misinformation, and loss of trust in our institutions. For months, governments and scientists have gradually filtered information, allowing conspiracy theories to flourish. I propose radical transparency. All data about 3i Atlas must be made public immediately. All meetings on the topic must be broadcast. All scientists must have access to observations. All humanity must be part of this discovery, not just an elite of scientists and politicians. This position resonated especially with younger generations and government transparency movements. It reflected the belief that democracy and openness were essential, even, or especially, when facing the unknown. The Terrestrial Priorities Bloc. Surprisingly small but tenacious, this group argued the world was spending too much attention and resources on 3i Atlas when there were urgent unsolved problems on Earth. Millions die from hunger, disease, and war, declared a representative from a developing African country. Climate change threatens our civilization, and we're talking about spending billions of dollars pursuing a space rock that's light years away and doesn't directly affect us. Yes, 3i Atlas is fascinating, but it shouldn't distract us from our responsibilities toward human beings suffering here and now. Any spending on space exploration must be secondary to solving terrestrial crises. This argument, though unpopular among space enthusiasts, touched an uncomfortable truth. Resources are finite, and choices about how to spend them reflect values and priorities. Was it moral to spend fortunes on space exploration while millions lacked clean water and basic medical care? January 30th, 2025. The Joint Declaration. After days of intense negotiations, the UN issued a historic compromise statement, known as the New York Declaration on Extraterrestrial Contact. Key points included: 1. Scientific transparency. All scientific data about 3i Atlas and future similar objects would be openly shared with the international scientific community and published in publicly accessible databases. 2. Prohibition on militarization. No nation would attempt to militarize responses to 3i Atlas or develop weapons specifically intended to attack extraterrestrial objects without international approval. 3. Global Research Fund. An international fund of $60 billion over 5 years would be established for research related to interstellar objects, advanced space propulsion, and astrobiology. 4. Coordinated Encounter Mission. The world's space agencies would collaborate on designing and launching a mission to reach 3i Atlas, with proportional contributions from all participating nations. 5. Contact Protocol. If signals of extraterrestrial intelligence were detected, or if 3i Atlas attempted to communicate, no nation would respond unilaterally. Any response would be decided collectively by an international committee of scientists, diplomats, and cultural representatives. The declaration was signed by 167 of the 193 member nations. Main dissents came from some states that refused to cede sovereignty in planetary defense matters, and others questioning the massive spending on space exploration. But it was a beginning. For the first time in history, humanity was acting truly as a unified species. February 5, 2025. Philosophical and religious impact. While politicians negotiated and scientists investigated, philosophers, theologians, and thinkers attempted to process the deeper implications of the discovery. Abrahamic religions, Christianity, Islam, Judaism, faced complex theological questions. If intelligent extraterrestrial life existed, did they have souls? Were they part of the divine plan? Did Christ also die for the sins of aliens on other planets? The Vatican issued a surprisingly progressive statement. The universe is vast, and God's creativity unlimited. If other forms of intelligence exist, they are also God's children, created in His image in ways we perhaps don't fully understand. This doesn't contradict our faith, it expands it. Islamic leaders issued similar statements, citing Quranic verses mentioning the vastness of Allah's creation and the possibility of other life forms. Eastern religions like Buddhism and Hinduism found the discovery less theologically disturbing. Both traditions already contemplated the existence of innumerable worlds and forms of consciousness. The universe is infinite and contains infinite possibilities, declared the Dalai Lama. That we've found evidence of other beings is wonderful, not frightening. Philosophers debated implications for concepts of human identity and existential meaning. If we weren't unique in the universe, what did it mean to be human? Was our civilization simply one among millions? Or did we have some special quality that distinguished us? German philosopher Jürgen Habermas wrote an influential essay titled Communication Beyond Species. The possibility of communicating with non-human intelligence forces us to reconsider the foundations of ethics, language, and rationality. What values are universal, transcending not just human cultures, but species? Does a cosmic ethics exist? February 10, 2025. Economic and technological impact. The private sector hadn't remained on the sidelines. Technology and aerospace companies saw in 3i Atlas both opportunity and threat. SpaceX, Blue Origin, and other private companies announced massive investments in advanced propulsion technologies. If an extraterrestrial civilization had achieved interstellar travel, humans should be able to do it too. The space race had acquired new urgency. Elon Musk tweeted, "3i Atlas proves interstellar travel is possible. If they can, we can." Goal: reach 0.1 c, 10% of light speed, in 20 years. Making humanity multiplanetary is no longer optional. Stocks of technology companies related to AI, robotics, and advanced materials skyrocketed. Investors bet that technologies needed to reach and study 3i Atlas would generate valuable commercial spin-offs, similar to how the Apollo program boosted multiple industries. Financial markets had experienced initial volatility but stabilized. After the initial shock, analysts concluded that 3i Atlas, though fascinating, wouldn't fundamentally alter the global economy in the short term. Life continued. Companies kept producing. Consumers kept consuming. But long-term, the implications were enormous. If humanity gained access to advanced technologies, new forms of energy, impossible materials, revolutionary propulsion methods, the global economy could transform completely within decades. February 15, 2025. Cultural and social impact. Popular culture absorbed the 3i Atlas phenomenon with enthusiasm. Films, television series, novels, video games, all incorporated themes of extraterrestrial contact with renewed urgency. Artists created works inspired by the object's mystery. Abstract paintings representing the solitary journey through interstellar darkness. Polished metal sculptures evoking the alien reflective surface. Musical compositions using sounds generated by radio waves from deep space. Educators noted a dramatic increase in student interest in STEM. science, technology, engineering, mathematics. Enrollments in astrophysics, aerospace engineering, and astrobiology programs tripled at universities worldwide. An entire generation was being inspired toward the stars. Social media continued being a battlefield of opinions. Hashtags 3i Atlas, First Contact, Not Alone dominated trends. Some users shared hope and optimism, others expressed fear. Many simply shared memes and wild speculation. New social movements emerged, groups believing 3i Atlas was a messenger of peace and cosmic wisdom, cults worshipping it as a deity, apocalyptic sects prophesying imminent destruction, and crucially, human unity movements seeing the discovery as catalyst to overcome national divisions and work as a species. February 20, 2025. The long-term perspective. Historians and futurists began contextualizing 3i Atlas within the broader arc of human civilization. Dr. Yuval Noah Harari, historian and author of *Sapiens*, wrote, "Every few centuries, humanity experiences an inflection point that redefines everything that comes after. The agricultural revolution 10,000 years ago, the scientific revolution 500 years ago, the digital revolution 50 years ago. The discovery of 3i Atlas could be the next inflection point. It marks the moment we stopped asking, 'Are we alone?' and started asking, 'Who are our cosmic neighbors?' All philosophy, religion, politics, and culture that comes after will be colored by this new understanding. We've stopped being cosmic orphans. We have cousins in the stars. We may never meet them face to face, but knowing they exist changes everything. It changes how we see ourselves. It changes our sense of purpose and destiny. And most important, it forces us to mature. A species that knows others are watching can't afford to behave with the irresponsibility of children fighting in a playground. We must be better, wiser, more united, or we risk being left behind in a universe that's clearly vaster, more populated, and more complex than we ever imagined." His words resonated deeply, because at the end of the day, 3i Atlas wasn't just a space object. It was a mirror in which humanity saw reflected its own insignificance and potential simultaneously. And while the object continued its silent journey toward distant stars, we remained here, looking upward, wondering what awaited us out there, and wondering if we were ready to discover it. Chapter 7. The Journey Continues. March 1st, 2025. Encounter Mission Design. At Kennedy Space Center in Florida, engineers from 12 nations worked side by side on something unprecedented, the Interstellar Encounter Mission, IEM, the most ambitious spacecraft ever conceived. The technical challenge was monumental. 3i Atlas was moving away from the Sun at 24.7 miles per second, more than 88,000 miles per hour. To reach it, the human spacecraft would have to match that velocity, then decelerate enough to perform a close encounter without crashing. Dr. Les Johnson, NASA propulsion physicist, explained the plan at a press conference. "We'll use a hybrid concept, combining the best of our current technologies with some radical innovations. The mission will be divided into 4 phases. Phase 1, launch and initial acceleration. We'll use the most powerful rocket available, probably an improved version of SpaceX's Starship or NASA's SLS, to leave Earth orbit. This will give us an initial velocity of approximately 9.3 miles per second. Phase 2, multiple gravity assists. The spacecraft will perform flybys of Venus twice, Earth once, and Jupiter once during the first 3 to 4 years. Each flyby will steal a bit of orbital angular momentum from those planets, accelerating the craft without spending fuel. With luck, we'll reach 34 to 37 miles per second. Phase 3. Long-duration ion propulsion. During the next 6 to 7 years, ion engines powered by nuclear reactors will provide continuous but gentle thrust, adding another 6 to 9 miles per second to our velocity. Phase 4. Encounter and study. Around 2035, if everything goes according to plan, we'll reach 3I Atlas. We'll deploy small sub-probes for even closer approaches, take high-resolution images, and analyze its composition using spectrographs and other instruments. The estimated cost had been refined to $21 billion. Enormous, yes, but distributed among multiple nations and over a decade, it was manageable. Less than what the world spent on ice cream each year, as one sarcastic commentator noted. March 15, 2025. The scientific instruments. The IEM spacecraft would carry an unprecedented suite of scientific instruments. High-resolution cameras, capable of resolving details down to 4 inches at a distance of 600 miles. If there were texts, symbols, or artificial features on 3I Atlas's surface, these cameras would detect them. Multi-wavelength spectrographs, from X-rays to far infrared, analyzing every photon emitted or reflected by the object to determine its exact chemical composition. Ultra-sensitive magnetometers, to detect weak magnetic fields that could indicate internal electrical currents or ferromagnetic materials. Radiation detectors, monitoring neutrons, gamma rays, and other emissions that could reveal internal nuclear processes. Penetrating radar, attempting to see inside the object using radio waves, similar to how ground-penetrating radars can detect underground structures. Dust analyzer, collecting any microscopic particles expelled by 3I Atlas which could contain clues about its internal composition. Laser communication system, to attempt sending signals directly to 3I Atlas from close distances, seeking any response. Dr. Ellen Stofan, planetary scientist, commented, "This mission is like sending a complete laboratory flying through the solar system. If there's anything to discover about 3I Atlas, these instruments will find it." April 1, 2025. The naming question. A surprisingly heated debate arose over what name to give the Encounter spacecraft. Millions of suggestions were received from the global public. Hope, proposed by Spain and several Latin American countries. Unity, proposed by the United States. Harmonia, proposed by Greece. Voyager 3, to continue the legacy of the legendary probes. Carl Sagan, honoring the famous astronomer and communicator. Zheng He, the Chinese explorer of the 15th century. In the end, a name was chosen that transcended nationalities and languages. Odyssey. Like Homer's epic, this would be an odyssey, a long, dangerous, and transformative journey into the unknown. Odyssey represents the human spirit of exploration, declared the project director. We don't know what we'll find at the end of this journey, but we know we must try. April 15, 2025. Accelerated construction. Odyssey's construction proceeded at an unprecedented pace. Normally, a complex space mission required 10 to 15 years from concept to launch, but the urgency of reaching 3I Atlas before it moved too far away compressed timelines drastically. Factories in the United States, Europe, Japan, China, and Russia worked 24/7 producing components. The compact nuclear reactors that would power the ion engines were being assembled in secure facilities. Long-range communication systems were rigorously tested. Engineers slept little and worked much, It was similar to the Apollo program atmosphere, but with an even deeper sense of purpose. They weren't competing against another nation. They were working together for all humanity. Young engineers, many barely graduated, spoke with awe about participating in the most important project in human history. And perhaps they were right. May 1, 2025. 3I Atlas. Final preparations. Meanwhile, 3I Atlas continued to be constantly monitored. It was now more than 2.5 astronomical units from the Sun, beyond Mars's orbit, and moving away at a rate of over 1.9 million miles per day. The world's most powerful telescopes followed its progress meticulously. Each night, dozens of observatories pointed toward that tiny point of light, recording its position with millisecond of arc precision. And what they observed was fascinating. The periodic accelerations continued. Every 6.7 hours, like clockwork, a small impulse was detected. The regularity was almost hypnotic. Some scientists joked they could set their watches by 3I Atlas's impulses. But there was something else. Detailed analysis of the acceleration pattern revealed subtle variations. They weren't completely identical each time. There were slight differences in magnitude and direction, as if the object were adjusting, navigating, correcting its course toward some distant target with exquisite precision. May 15, 2025. The beacon theory. A new theory emerged among scientists, proposed by Italian astrophysicist Dr. Roberto Battiston. The beacon theory. Consider this possibility, Battiston explained in a paper published in Nature. 3I Atlas might not be simply an exploration probe. It could be an interstellar beacon, a deliberately bright and active marker designed to be detected by emerging civilizations like ours. The logic was intriguing. If an advanced civilization wanted to signal its existence to younger species without directly intervening, how would it do so? Sending radio signals would require knowing where to look and when, but sending physical objects through the galaxy, objects designed to be obviously artificial when detected, would be a patient but effective strategy. 3I Atlas has all the characteristics you'd design into a beacon, Battiston continued. It's bright, more reflective than almost any natural object. It's geometrically regular, easy to distinguish from irregular asteroids. It shows controlled accelerations, an unmistakable signal of artificiality, and it passes near stars with habitable planets, increasing detection probability. If this was true, then perhaps the galaxy was seeded with thousands or millions of such beacons, silently crossing between stars, patiently waiting to be discovered by civilizations technologically mature enough. And that discovery would itself be a test. You've reached the development level where you can detect us. Welcome to the Cosmic Club. Now you know you're not alone. June 1, 2025. Global Reflections. As the 6th month since 3I Atlas's discovery approached, the world had changed in subtle but profound ways. Crime rates had decreased slightly in many countries, as if cosmic perspective made human disputes seem more trivial. International cooperation on other issues, climate change, trade, human rights, had marginally improved. When you share a small planet in a vast universe, differences seem less insurmountable. Discussions about life's meaning flourished in coffee shops, universities, and online forums. Amateur and professional philosophers debated existential questions with renewed passion. A global survey showed that 78% of people felt more optimistic about humanity's future after 3I Atlas's discovery, despite the uncertainty. There was something fundamentally inspiring about knowing interstellar travel was possible. that technology could overcome unimaginable distances, that intelligence could persist through eons. If they could do it, so can we. June 15, 2025. The launch window. Odyssey engineers announced the optimal launch window would be between January and March 2026, barely 7 to 9 months in the future. It was incredibly ambitious, but feasible if everything proceeded without major setbacks. "We're on track," declared the project director with cautious optimism. "Components are being assembled. Testing is advancing. If the engineering gods are kind, we'll launch on time." The pressure was immense. A delay of months could make the mission significantly more difficult, or even impossible. Every day counted. July 1, 2025. The unanswered question. As the year advanced, one question persisted in millions of minds. What would happen when Odyssey reached 3I Atlas in 2035? Optimists imagined a peaceful encounter. Perhaps 3I Atlas would respond to Odyssey's signals. Perhaps it would open hatches and reveal its interior. Perhaps it would transmit a message from its creators, a greeting, a warning, an invitation. Pessimists feared the worst. Perhaps 3I Atlas was a dormant weapon that would activate if disturbed. Perhaps it was a trap designed for curious civilizations. Perhaps the simple act of approaching would trigger some defense mechanism. Realists recognized the most likely outcome was something in between. Perhaps 3I Atlas was simply an ancient machine without active intelligence, incapable of responding, but full of information if you knew how to read it, like deciphering Egyptian hieroglyphs or alien machine code. But nobody really knew, and that uncertainty was both terrifying and electrifying. July 15, 2025. 3I Atlas's legacy. Regardless of what happened in 2035, 3I Atlas had already left an indelible legacy. It had unified humanity in ways no crisis or ideology had achieved. When facing the cosmos's vastness, national borders seem like arbitrary lines in the sand. It had inspired a generation to look toward the stars with awe and ambition. Children growing up in 2025 dreamed of being astrophysicists, aerospace engineers, xenologists. It had challenged dogmas and forced humanity to reconsider fundamental assumptions about its place in the universe. And it had demonstrated the impossible was possible. If a civilization could build something that crossed the abyss between stars, then the limits of what technology could achieve were far broader than we imagined. Dr. Michio Kaku expressed it eloquently in a final interview. 3I Atlas is a reminder that the universe is stranger, more wonderful, and more populated than our ancestors ever dreamed. It's an invitation to grow, to mature as a species, to join what may be a galactic community of civilizations. We don't know if we'll see them in our lifetimes, perhaps not, but we know they're out there, and that changes everything. We're no longer alone, and we never will be again. Epilogue. Toward Infinity, November 14, 2025. 1 year after discovery. Exactly 1 year after Gennady Borisov pointed his telescope toward Ursa Major and changed history, the world paused to commemorate. In cities on every continent, sky vigils were held, events where millions of people went out into the night armed with telescopes, binoculars, or simply their eyes, looking upward, searching for that tiny point of light that was now too distant and faint to see without professional instruments. I-Atlas was now more than 4 astronomical units from the Sun, beyond Jupiter's orbit. In approximately 3 years, it would cross Neptune's orbit and enter the heliopause, the boundary where solar wind yields to the interstellar medium, and after that it would continue toward Proxima Centauri for 6,000 more years, but it wouldn't travel alone. Because in January 2026, if everything went according to plan, Odyssey would launch from Earth, and it would begin its own odyssey to reach the mysterious visitor. It would take a decade of silent travel through the void, a decade of uncertainty and hope. But at the end, if calculations were correct, if luck accompanied them, if the gods, any god, smiled on this audacious enterprise, humanity would touch the extraterrestrial for the first time, and in that moment, everything would change again. Somewhere between the stars, 3i Atlas continued its millennial journey. It didn't know it was being watched, or perhaps it did. It felt no curiosity or fear. Or perhaps it had some form of experience we couldn't comprehend. It simply navigated, adjusted, accelerated gently every 6.7 hours, correcting its course with infinitesimal precision toward a destination programmed eons ago by minds that perhaps still existed, or perhaps had long since ascended, evolved, or disappeared into cosmic dust. It was a messenger, an explorer, a silent witness to the cosmos, and we, small creatures on a blue planet, had the privilege of seeing it pass, of knowing we weren't alone, and of daring to follow it toward infinity.